In this lesson, we'll be setting up a multi-axis contour toolpath. After completing this lesson, you'll be able to create a taper mill, modify tool parameters, and create a multi-axis contour toolpath. Let's get started by uploading the supplied file, multi-axis contour. This is the same file we used in the previous week's lessons, but now we want to start to explore some simultaneous multi-axis toolpaths. So far, when we machine this part, we used multi-axis positioning, or 3+2 machining. This means that we were machining in 2 and 3 axes, but using the additional A and B axes for rotation to position our tool. Now we want to explore how the tool can move in all axes simultaneously. And to get started, we're going to go into our multi-axis drop-down and select multi-axis contour. We're going to be using this tool to follow the edge of a curve around a part and see how we can control it in terms of getting the tool to shift at different angles and move around a contour which we select. There are some things we need to understand about this toolpath, so we're going to take it one step at a time, looking at setting up the toolpath first, then going back and controlling some of the parameters. The first thing that we need to know about multi-axis contour is there are only certain types of tools that can work for this toolpath. We need to get started by creating a new tool. We're going to come into our cutter section and we want to create a taper mill tool. We're going to be using the inch unit system, and notice the preview on the screen has a fairly large tool. We want to make something that's a little bit smaller, so we're going to start by changing the diameter of the tool to 0.05. Notice instantly that most of the parameters change to be much smaller, and this is not a realistic tool. So we need to continue to modify some of these parameters. The body length is going to be 1.25 inches. The overall length has to be a little bit longer, so we're going to set this up at 2 inches, which gives us 3/4 of an inch inside of the holder. Next, we need to modify things like the flute length and the shoulder length. I'm going to modify the shoulder length first because this value has to be longer than the flute length. Next, the flute length we're going to set up at 0.425. The shaft diameter in this case is going to be set up at 0.2 inches. So you'll notice how that changes the preview on the screen. We also can come into our post-processor section and set this up as tool number 9. In the general section, we're going to add a description of taper mill. We're just simply creating this to explore these toolpaths, and again, I can't stress enough that the tools that you create or use need to represent a real tool. So if you're not downloading them directly from your manufacturer and creating your own tool library, you need to make sure that you use the tool creation and replicate everything that you have. If your tool supplier doesn't supply a CAD file for the tool, then you should have all the parameters on their website that you can populate and create a representation of it. From here, we're going to select OK, and now we have a tool that we can use. In the geometry section, we have to select a contour. I'm going to get started by selecting the inside edge contour here, and I know what you're probably thinking. This is only a 2D toolpath. There's nothing about this that is multi-axis, but this is exactly what we want to explore. I'm not going to touch any other settings. I'm simply going to say OK, allow it to create that toolpath, and notice that we get a warning. It tells us that there's no toolpath here. So if we take a look at this, the contact offset value needs to be greater than or equal to 0. So it's telling us that the contact offset for the cutter radius or the corner radius of our tool is causing a problem. So if we go back in and we edit our tool, we take a look at its parameters. It has a problem with the corner radius value here. Now, in reality, we need to make sure that this is, again, a real tool, and the value we're going to use is 0.02. Then we're going to use Ctrl-G to regenerate the toolpath. And with that larger value, we can now see that we have a toolpath on the screen. So again, I can't stress enough the importance of creating a real tool, because there are some instances where these parameters will cause failures in your toolpath. The multi-axis contour toolpath, again, will not work for all tools. If you used a chamfer mill, for example, it wouldn't be able to create a toolpath. It has to have a specific tool. Now that we have a toolpath, we want to go to Simulate. I'm going to make sure that my stock is off and my toolpath is off, and I'm going to simply play through this so I can see exactly what the tool is doing. You might want to slow the speed down and just take a look at exactly what the tool is doing and where it's going. If we zoom in on this, you can see that the rounded portion of the tool is just touching the edge. So again, this is a great way for us to come back and simply clean up the edges to ensure that we don't have a sharp edge or corner on our part. And you can see that the tool is in fact rotating around, and it's changing based on the orientation of the tool relative to the geometry. Again, what we're going to be doing is exploring this toolpath by making changes, adjusting the contour and the parameters, so that way we understand what each of these does in 3 axes as well as 5 at the same time. So from here, let's make sure that we save our part before we move on to the next step.
Thank you for watching our channel. Please like, share and subscribe our channel, and don't forget to press on bell icon.